Okay students, this is Sudh Pandey and now we are going to start our new topic. The topic is surface tension. So in this lecture we will discuss about some unique property of the fluids. Before it I have completed one property that belongs to solid only, and the property is elasticity, as you know. Okay. So surface tension is what, and as I have told you that it is basically refers for only the fluids and not for the complete fluid, but we can say that only for the surface of the fluid. So this is a unique property which belongs to the surface of the fluid. So question is what is surface tension and how it comes in play. There are several questions in our mind. So what should we do now? Let's get started and we will see what and how we can say, how we can explain the surface tension in the very easiest way. And one more thing I would like to tell you that surface tension is a very tasty topic, and the reason why I am saying like this, that it is a very tasty topic, because have you taste a soup, and when we taste soup, then we can simply say that in hot soup we feel more taste, but if the soup is cold one, then I don't think that you you feel the same taste. Why this happens? So this happens only due to surface tension. That's why I am saying that it is a very tasty topic. So let's get started. Surface tension. So surface tension is basically we have to understand the configuration of the layer of the fluid. So here, as you can see on the screen, it is clear written that a molecule and this molecule well inside a body, means we can say the molecule that is completely inside the body, inside. Clear? So if we see that molecule which is inside, that is surrounded by similar particles from all sides. It means if we take a container like this way, suppose this is the container, then we can say okay, now we see like this way. So here one water molecule, let's suppose, and here another water molecules, it is another water molecule. So there are several molecules, but each and every molecule we can simply say that it is surrounded by the similar type of the molecules. So this is the talk about the molecule which is inside the fluid, means in some depth, and not necessary that the depth is too much, it may be slightly in millimeter also. So this is the first scene I have created here, that a fluid is there, and inside it there are molecules, and that molecule is surrounded by the similar molecules around itself. So this is the first scene. I hope that it is clear now. But if we see a molecule on the surface, means if we take the molecules, let's suppose this is the surface of the fluid, then whatever the molecules are here only, although all the molecules are water itself, but what is the difference between these molecules and these molecules? So this is one basic difference is there, and the difference is what the difference is this, that the deeper molecules means these molecules are we can simply say that surrounded by the similar molecules. Okay, but in case of this one means the molecules which are at surface, upper side there are air molecules, clear. So in upper side there are air molecules, but below there are water molecules or fluid molecules. So there are two scenes are here, and in first scene we have a molecule which is in deeper side, and that is surrounded by the similar molecules of that fluid. And on the other hand side we have another scenario, and in that scenario when we see the molecules which lies at the surface, then those molecules are surrounded by two types of molecules. One is surrounded by air molecules, whereas the other is surrounded by the fluid molecules itself. So this is the basic difference between the molecules of the surface and the molecules which are at the deeper level. So I hope that this basic difference is now clear in your mind. Okay, so now we can say that a molecule of water well inside the bulk experience forces from water molecules from all sides. It means because we can say that the molecules are surrounded by the same molecules, so each and every molecules will apply the same force. But as we have discussed that at the surface the molecules is surrounded by air molecules as well as the water molecules. It means there is some difference of the force. So this difference creates, and where it creates a resultant force on the surface of the fluid. So when the molecules is at surface interact with air, as I have told you, the molecules from above and water molecules from below, this asymmetric force. So asymmetric means we have certain resultant force, because let's see, we make another diagram for you and make it clear that what I am trying to explain you. So basically we can say that this is the molecule which is surrounded by the same type of molecules, like this way. Okay, so every molecules exert force like this way, you can simply say. And because the nature and property, there are uniformity everywhere, so force must be same and equal, so it will be cancelled out. But if we take a molecules which is on surface, so if we take a molecule which is on surface, means we can simply say this is the molecule which is on surface, so it is surrounded below side from the same type of molecule. But if we see above side, then we have a molecule of air. So these forces will be different with that one. I hope that it is now clear to all of you. So it means there must be some resultant force which will experienced by the molecule which is at surface. Okay, so that's why this is called the asymmetric force, because in the previous case when the molecule is surrounded by similar molecules, then the forces are equal, or we can say symmetric. But the molecule which is at the surface are surrounded by different types of molecules. There are air molecules as well as fluid molecules, so there are forces which are not symmetrical, and we simply say that asymmetrical forces, and this asymmetrical force is responsible for the surface tension. Okay, so I hope that this thing is now clear in your mind. Okay, now what? The force between two molecules decreases as the separation between them increases. We know very well that F is always inversely proportional to R square in case of your electrostatics, or in many other forces are there like nuclear forces. So there are F that is proportional to R to the power 6 or F proportional to R to the power 12. It means we can simply say that if R increases anywhere, if R increases, then the force decreases. So this thing you know very well. Now what? The force becomes negligible if the separation exceeds 10 to 15 molecular diameters. What does it mean? It means that if we talk about the molecular distances, so for it I would like to draw a diagram for you like this way. Suppose this is a container, and in this container you have several molecules like this way. Okay, so the basic this is called diameter of one molecule. Let's suppose the diameter is d, and because all the molecules are similar, so all have diameter d. Now suppose we have one molecule which is here only and the other molecule which is here only, and the distance between these two molecules which is nearly 10 to 15 molecular diameters, means it is either 10d or we can say either 15d. 10d2 we can say, not or 2, 10d2 15d, then we can simply say that it is sufficient distance to become force negligible. Okay, so if the force is a little bit felt by molecules, it means the distance between those molecules are less. And but if the distance between the molecules is nearly 10 to 15 molecular diameters, then we can simply say that force will be too less and we can neglect it. Okay, so if we go 10 to 15 molecular diameters deep, a molecule find equal forces from all directions. Okay, so this thing is clear to all of you now, as I believe. Now what? Now we have to do an experiment. We have to feel the concept of surface tension and how we can feel it. So simply what you have to do, you have to imagine a line AB drawn on the surface of a liquid as shown in figure. So this is your figure, and in this figure you can see that an imaginary line is drawn over the surface. Okay, so the line divides the surface in two parts. So the surface is divided by the two parts. We can say that the two parts are symmetrical to each other when we draw an imaginary line on the surface. Okay, so surface on one side and the surface on the other side of the line, that must be uniform. Okay, so means we can simply say that we have divided the surface of the fluid in two equal parts. Let us call them surface to the left of the line and surface to the right of the line. So we have chosen that this is the suppose right side and this is suppose the left side, which is calculated, which can be seen from the imaginary line. Okay. Now what? It is found that the two parts of the surface pull each other with a force proportional to the length of the line AB. It means if we have suppose this is your surface, and this surface is uniformly distributed in two parts by an imaginary line. Let's suppose the line is AB. So whatever portion is on the right hand side, the same portion is on the left hand side. So because the amount or quantity, whatever we can say, the number of molecules are uniform both sides. So we can say that the force whatever is experienced by the line, that depends on its length only. So this is the unique feature. Means if we draw, suppose this is a line which having length x1, and now if we place another line in place of here, let's suppose now we place a new line, this one, this is again let's suppose P and Q, and the distance is your x2. So if as I have draw the diagram, and we find that x1 is greater than x2, the length of the imaginary line. So x1 is the length of the line AB, and x2 is the length of line PQ. So if the length is greater, now because we have seen clear that the line divides the surface of the fluid in two equal parts, but if the line is having greater length with compared to the a line with having smaller length, then the force whatever is felt by larger line or the greater line or the longer line, that will be also greater with compared to the force felt by the smaller or shortened line drawn over the surface. These forces of pull are perpendicular to the line separating the two parts. So this is the one wonderful result here, that whatever force you can see, either larger or smaller, doesn't matter, but one thing is clear, that the direction of force will be perpendicular to the imaginary line. Okay. So in this respect, the surface of the liquid behaves like a stretched rubber sheet. So this is we can say that this is the natural concept, God-given concept. There is a asymmetrical force. Whenever there is a asymmetrical force, we can say like this way. So whenever there is an asymmetrical force, then there must be a unbalanced condition, and we find a resultant force which acted in some particular direction, because vector force is a vector. So what is the direction? So direction is perpendicular to the line what we have drawn on the surface of the fluid. Doesn't matter the force is greater or smaller, but the direction will be fixed, and that the fixed direction is the perpendicular. So let's suppose if we draw a line here, and one force is like this way and the other force is like this way, both are the same in amount, both sides. So the line seems to be stretched like this way. Like in elasticity, you have seen that when there is a wire and we attach some weight over it, then a tension is developed, and due to tension some length of the wire increases. So like this way, this is the length which increase. In the same sense, we can see here that when forces acted in the perpendicular direction to the imaginary line, so it seems that the line is stretching, and it behaves like a rubber sheet. Now what? The rubber sheet which is stretched from all sides is in the state of tension. So as you can simply say that a force is applied by the molecules, and which type of force? That is asymmetrical force. So asymmetrical force is applied, and due to asymmetrical force, so there is some stretching is there, we can say change in configuration is there likewise. So we can simply say that this condition arises a tension on the surface, and we can say we can not say, we can see only that any part of the sheet pulls the adjacent part towards itself. So if as I have told you that in elasticity, this is your wire, and when we apply force, then it slightly increases its length. Okay, so now if we remove the force, then what will happen? It will regain its original shape and size. This is the elasticity. So something like that phenomena is going on. The force is on the image line which is acted outwards, means the forces are trying to stretch the surface, but the surface, due to inertia, we can simply say, tries to maintain its original shape. So it pull towards each other, the two parts pulls towards each other. So I hope this thing is now clear to all of you. Now we will come finally the definition, whatever we have learned. So we have a definition. What type of definition is there? That is if F be the common magnitude of the forces. As I have told you that the both sides have equal forces, so it is 100% sure that the magnitude must be equal. So any magnitude you can take here, and the magnitude exerted on each other side by the two parts of the surface across a line of length L. So surface tension is basically force per unit length. So force, and what type of force? Once again, asymmetrical force. So that force applied on per unit length, because I have told you that if we have a larger length of the imaginary line, then the force will be greater, and if the smaller, then the force will be also smaller. So force per unit length is simply express the surface tension, and you can simply say that its SI unit will be Newton meter inverse, because the unit of force is Newton and the unit of length is meter, so it will be Newton meter inverse. So this thing is now clear in your mind, as I believe. Okay, now what? Here is your example number 14.4 from the book from the book written by Sir S.C. Verma, that is Concept of Physics. In this question, firstly we read it, that what is given here. Water is kept in a beaker of radius 5 centimeter. So consider a diameter of the beaker on the surface of the water. It means indirectly it is clear that the diameter is behave like the length of the we can say that imaginary lines, and that is nothing but 2r, and 2 and r is given 5 centimeters, so it will be 5 into 10 power minus 2. So it can be written as 10 to the power minus 1, or we can say 0.1. So this is the indirect way to given the length of the imaginary lines. Now what? Find the force by which the surface on other side, so one side of the diameter pulls the surface on the other side, and the surface tension is given. So surface tension, that is S, and given 0.075. And we know the formula surface tension is force per unit length experienced by the imaginary line. Okay, so force will be nothing but S into L, surface tension, that is 0.075, and multiply by L, that is 0.1. So it will be 0.0075 Newton. So this is the amount of force which is applied by one side of the surface of the fluid, which will attract the other side of the surface of the fluid, and the same amount of force will be applied on the other side of the surface of the fluid as well. So this is quite easy question. I believe that this question is clear to all of you. Okay, so let connect with me, and I will try to explain each and everything to you, whether it is the objective type question, subjective type question, whatever question is given in your book, each and everything in detail I will discuss as I have discussed here only. Okay, so stay with me. Thank you very much.